Hi Chem students, welcome to today's lesson over fission versus fusion. I'm starting on page 7 in your notes, have something to write with and a highlighter. Nuclear fission. It occurs by bombardment of uranium-235 or plutonium-239 with neutrons, which are fissionable isotopes. For example, uranium-235 splits into several different smaller elements and also releases more neutrons and a large quantity of energy. If enough of the fissionable isotope is present, the neutrons will sustain a chain reaction. So you see the uranium-235 here. We've got these neutrons that are hitting the uranium-235, causing it to split apart. Well, it splits apart into two other products, but then if there's more neutrons available to hit those, this sustains a chain reaction. It splits apart into new stuff, and then those things split apart, and it keeps continuing. It says nuclear fission releases huge quantities of energy, gram for gram, at least 1,000,000 times more than the energy produced in any chemical reaction. So realize in fission, you have one large thing splitting apart into smaller things. Nuclear power plants. These are controlled nuclear fission reactions with 3 to 5% enriched uranium-235. So I have a diagram of a power plant here. I highly recommend you go to the website and watch this video. It will completely explain how a nuclear power plant works if you're interested. You don't need to know for our class, but it may interest you. Okay, some pros for nuclear power plants are that they are an alternative to fossil fuels and they do not release greenhouse gases or pollute the environment in other ways. Then we have the cons. They're expensive, at least initially. Now, the storage of spent fuel remains dangerously radioactive for thousands of years. That's where it's dangerous, is that the product of the nuclear power plant is this radioactive material that remains that way for thousands of years. You can't get rid of it. There have been some accidents with these nuclear power plants. So there's 3 that I want us to discuss. The first one is 3 Mile Island in Pennsylvania in 1979. It occurred because of a partial meltdown of the core caused by equipment malfunctions and design-related problems and human errors. Almost all of the radiation was contained, so this is good. The radiation that was released had negligible effects on living organisms and the environment. This brought about sweeping changes in design and the operation of nuclear power plants. So the good news is in 3 Mile Island, most of the radiation was contained. Okay, the next accident was Chernobyl, and you've probably heard about this. It occurred in 1986. There's been movies made about it because really it is almost like a real-life horror film. So the reactor lid was blown off due to a buildup of steam. A massive fire started and radioactive debris was released into the atmosphere. This was caused by flawed reactor design, so a poor design caused this one. Also, inadequately trained personnel and a disregard for safety. So I know you think I'm crazy when I emphasize safety in the lab, but Chernobyl was caused because of a disregard for safety. Many firefighters died due to the intense radiation exposure. Other people were harmed in both the short term and long term by the effects of radiation exposure. So I have some pictures of the long-term effects of this radiation. Here you can see I have a cow with 2 heads. This caused mutations in the cow's DNA, probably the mother's DNA. And then when she reproduced, we've got some mutants that have formed. Same here, you can see a child that's born with only 1 arm. Also, his body is very disproportionate. His arms are much longer than they should be. Here are some of the burns caused by the radiation on the legs of this person and then on the neck of this person. Radiation definitely will affect the thyroid. So you can see most likely here he's got a very enlarged thyroid due to the effects of the radiation. Lastly, I'm going to talk about Fukushima in Japan. This happened in 2011. I was actually teaching that year, so it wasn't that long ago. Equipment failures initiated by an earthquake resulting in a tsunami. So there was an earthquake and a tsunami that initiated this, which are natural events, but we as humans can't prevent these. This resulted in nuclear meltdowns and release of radioactive materials. Health effects are still being determined. So we don't know the long-term result of this one because it hasn't been long enough. Then we have nuclear weapons. So nuclear weapons are uncontrolled nuclear fission reactions where 90 to 95% of enriched uranium or plutonium-239. In World War II, we used a couple of these. We had Little Boy and Fat Man. Little Boy utilized uranium, and it was dropped on Hiroshima, so you can see a picture. And then Fat Man was the plutonium, and it was dropped on Nagasaki. So I've got pictures of both of those that you can look at and see the difference in the effects. So nuclear power plants and nuclear weapons both use fission. Now let's talk about fusion. Nuclear fusion involves forcing two relatively small nuclei to combine or fuse into one nucleus. So fusion, I want you to think about fusing together. As with fission, the amount of energy released can be huge due to the mass energy conversion. In fact, nuclear fusion liberates 3 to 10 times more energy than fission. So fission is a bomb. Fusion is 3 to 10 times stronger than that. Nuclear fusion powers our stars, including our sun. In this way, nuclear fusion can be thought of as the source of almost all the energy on the planet. Scientists have not yet found a way to sustain a beneficial nuclear fusion reaction on Earth. In our example, we've got deuterium fusing with tritium to form helium. So we've got two smaller atoms coming together and fusing or combining to form a larger product, in this case, helium. Okay, so this exercise says examine the 4 reactions to the right. Can you identify fission? Can you identify fusion? Which one is the chemical reaction? So go ahead and pause the video and see if you can fill this out on your own. When you come back, I will have an explanation. Okay, welcome back. I want to take a closer look at the 4 reactions to the right. So which one is fission? Hopefully you put D because D is the correct answer for fission. And what we can see in this one is we have one big substance breaking down to form 2 smaller substances. Which one is fusion? Hopefully you put B because in B what we can see is we've got 2 small combining to form one bigger substance. And then it says which one is the chemical reaction. Hopefully you were able to see that C is the chemical reaction. Here we've got water. It's actually breaking down to form hydrogen and oxygen. We call this the decomposition of water. And what we can see on this is on both sides of our reaction, we've got 4 hydrogen and 4 oxygen atoms. No new substance has been created, so we know it's a chemical reaction. Okay, lastly, arrange the following in order from least to most energy released during a reaction. Again, go ahead and pause it and see if you can do this on your own. Okay, welcome back. Hopefully you got chemical being the least, fission being in the middle, and fusion releasing the most energy. We're coming to the end of our lesson for today. In our lesson, we reviewed fission versus fusion and how fission fuels nuclear power plants and a few nuclear disasters we've encountered over the years. I hope you found this tutorial to be helpful. Please ask your teacher for help in class. Have a great day.